Hey, chemistry class. During first semester, we began to just scratch the surface of some of the things that we notice happening when chemical reactions happening. And we're going to be dealing with that a lot more in the future. And the first thing we're going to be talking about is what happens when there's a change in energy in a chemical reaction. And when we're dealing with a change in energy, we can usually feel this as temperature. It sometimes happens as something like light or sound, but we're always going to be using one of two terms to describe a change in energy. And those terms are what we call endothermic and exothermic. So, a change of energy always occurs when a chemical reaction happens. If the reaction produces energy, we say that reaction is exothermic. So in a very practical sense, an exothermic reaction feels hot because energy is coming out of the chemicals and into your skin. So we say that's exothermic. If the reaction takes in energy, we say that this is endothermic. And endothermic reactions feel cold because that energy has to come from somewhere. And if you're feeling it, chances are that energy is coming out of you. So we say that it feels cold. But really, we're just talking about a change in energy. So it's either exothermic or it's endothermic. And one way that we can represent endothermic or exothermic reactions is using something called an energy graph. Energy graphs chart the total amount of energy that the reaction has from the beginning to the end. Now, you can determine if something is exothermic or endothermic by simply looking at the graph. Now, a couple things to note about the graph. We always have a starting point for what we call our reactants. These are the chemicals that we are mixing together. And we also have an endpoint, which is what we call the product, or what gets produced by the reaction. Now, delta H right here, this is what we're using to represent our total change in energy. Change in energy. Energy being the capital H value that we have right here. And this bottom reaction right here, or bottom axis, I should say, I know it says reaction pathway, but I kind of want you guys to think about this as being a measurement of time. So this is at time 0 when the reaction begins. This is whenever the reaction ends. I'm going to call it time x. And between 0 and x, this is how long it takes for the reaction to occur. So this would be the change in energy as a product or a function of time. Now moving on, exothermic versus endothermic graphs. The graphs are going to be opposites of each other because one is taking in energy and one is losing energy. The top one is what we will call exothermic, and as you can see, we start with our reactants up top, we end with our products down below. The total energy has decreased. It started here and it's moved down. And when there's a total energy decrease, we have to say that that energy exits the reaction. And so this is exothermic, kind of like the word exit. Now on the flip side, we have a total energy increase on the bottom one. We start down here and we end up top. So this has been an energy increase. So energy has had to enter the reaction, and that's why we use endothermic. Just kind of a way to remember things. If something is exiting the reaction, it is exothermic. If the energy is entering the reaction, it is endothermic. So that's a good way of keeping things straight. Now, there's one other way that we can think about this, and this is what I call the building analogy. So with the building analogy, if something is exothermic, that means we're starting with a lot of energy and we're ending with not much energy at all, and so all that energy has had to exit the reaction. Well, if I was to finish this picture right here, I could draw it like this. Maybe I'd add some clouds in the sky, some trees out here, something like that. You could see that this is kind of like we're exiting a building. So this is what we would refer to as exothermic, or exiting the building. Now, endothermic is going to be the exact opposite. We're starting with a low amount of energy. That energy comes from somewhere, and then we end with a fairly high amount of energy. So if you can think of this kind of like the door into a room, we have to enter the room. So this would be our endothermic example. So we're either exiting or we're entering something. Energy in the same way exits or enters the reaction, and so we're keeping track of it by calling something endothermic or exothermic. I hope that helps, and we'll see you in class.